Hi, it's Jo Karen Hudson. We're going to be working today with rationalizing the denominator. Explain in words what it means to rationalize the denominator. It means that we are going to replace the irrational number in the denominator with one that is rational. Replacing the irrational number with a number that is rational. Now we have a strategy for doing that. Starting on the first one, I have 1 over the square root of 2. I'm going to look at that irrational part, which is the square root of 2. Whatever the irrational part is, I'm going to multiply the numerator and the denominator by that irrational part. So I have 1 times the square root of 2, which makes the square root of 2. And then I have the square root of 2 times the square root of 2, which is the square root of 4. So now I have the square root of 2 over, and the square root of 4 turns back into 2. Example 2. I'm going to, well, first of all, I noticed that the square root of 28 will break down, and it's easier to break it down and to keep the numbers smaller. So my chart, let's see, 1 squared is 1, 4, 9, 16. I believe that's big enough. 6 square roots of 5. The square root of 28 has a perfect square of 4 in it. So the square root of 28 turns into the square root of 4 times the square root of 7, which gives me 6 square roots of 5 over 2 square roots of 7. And I could go ahead and take advantage of the fact that 6 divided by 2 is 3 and convert this to 3 square roots of 5 over the square root of 7. 2 goes into 6 3 times, and 2 goes into itself 1 time. So it's 3 square roots of 5 over 7. And then I notice that I have this irrational in the denominator to take care of. So I'm going to multiply the numerator and the denominator by that irrational part, the square root of 7. So that I have 3 square roots of 35, because 5 times 7 is 35, over the square root of 7 times the square root of 7 is the square root of 49, which becomes 7. The square root of 17 over 3 times the square root of 17 over 15. If I multiply the two together, I'll have the square root of 289 over the square root of 45. I know that the square root of 289 is 17 because I multiplied 17 times 17 to get it. There is a perfect square, let's see, 1, 4, 9, that goes into 45, and it is 9. So I'm going to break that down. Square root of 9 times the square root of 5. So now that will become 17 over the square root of 9 is 3 square roots of 5. But you see, I still have this radical in the denominator. It's the square root of 5, so I'm going to multiply the numerator and the denominator by the square root of 5. That will give me 17 square roots of 5 over 3 times. When I multiply the square root of 5 times the square root of 5, I get the square root of 25, which becomes 5. So now I have 17 square roots of 5 over 15. Six square roots of 5 over the square root of n. The irrational part here is the square root of n, so I'm going to multiply the numerator by the square root of n and the denominator by the square root of n, so that I have 6 square roots of 5 times n is 5n, and then I have the square root of n times the square root of n is the square root of n squared. When we have the square root of n squared, 6 square roots of 5n over the square root of n squared automatically becomes n, because 2 goes into 2 one time. Now, as I look at this next problem, I notice y squared in there, and I know that a y squared will come out of a square root, so I think I'll just take that out first. The square root of y squared is y, because 2 goes into 2 one time, so I'll go ahead and write my problem down as y square roots of 5x over the square root of 7. And then I'm going to rationalize the denominator. I'm going to multiply the numerator by the square root of 7 and the denominator by the square root of 7, so that I'll have y square roots of 35x over square root of 7 times the square root of 7 is the square root of 49, which becomes 7. Final answer there. When I work this next problem, as soon as I see it, I notice that 15 divides by 5, so as I write my problem down, I'm going to go ahead and say 5 will go into 15, or 15 divided by 5 is 3, and I'm going to write it down as 3x to the 6th, y to the 14th over the square root of z. And then I notice that these are even numbers, so that the square root of x to the 6th and the square root of y to the 14th will break down. 2 goes into 6 3 times, so I'm going to bring out an x cubed. 2 goes into 14 7 times, so I'm going to bring out a y to the 7th. The square root of 3 will be left inside, and the square root of z is still in the denominator. So now I've got to rationalize the denominator. I'm going to multiply the numerator and the denominator by the square root of z, so that I will have x cubed y to the 7th times the square root of 3 times z, which is 3z. And in the denominator, I'm going to have the square root of z times the square root of z, which is the square root of z squared, which would just become z. Final answer there. Continuing with multiplying radicals together, I'm going to use the distributive property here and multiply the square root of 7 times both of these. The square root of 7 times the square root of 5 would be the square root of 35. The square root of 7 times the square root of 7 would be the square root of 49, which just becomes 7. Square root of 35 minus 7. Now this one looks a little messy. I'm going to have to FOIL the first, the outer, and then the inner and the last. And I'm going to write it all down so that I think that it would be easier for you to understand if I write it all down. I'll start off with 2 square roots of 3 times 3 square roots of 2 for the first, plus 2 square roots of 3 times negative the square root of 7. Then I'll do the inside and the last, plus 5 times 3 square roots of 2, plus 5 times negative square root of 7. So when I multiply, I'll have those two to multiply together. Let's see, 2 times 3 is 6, and the square root of 3 times the square root of 2 is the square root of 6, plus, well, it won't be plus because I have a positive times a negative. A positive times a negative will give me a negative 2 square roots of 3 times 7, which is 21. And then I'll multiply those together. That will give me plus 15 square roots of 2. And the last, I have a positive times a negative, which will give me negative 5 square roots of 7. There are no like terms there. This is my final answer. Here's one to square. When I square something, that means I multiply it by itself. Multiply it times itself. So I'm going to FOIL this out. I'll have the first and the outside. 2 times 2 is 4. The outside would give me minus 6 square roots of a. And then I'll do the inside and the last. The inside would give me minus 6 square roots of a. The last, I have a negative times a negative, which gives me a positive 9. And the square root of a times the square root of a gives me the square root of a squared, which becomes a. So combining the like terms, I'll have 4 Negative 6 and negative 6 would give us negative 12 square roots of a plus 9a. Final answer there. Now here I have conjugate pairs, so I know that the outside and the inside are going to drop out. I may show the steps on some of them, but I will not show it on all of them. I'm going to do the first and the outside. The square root of 3 times the square root of 3 would be the square root of 9, which would turn back into a 3. The outside would give me negative 5 square roots of 3. And the inside would give me positive 5 square roots of 3. You see those drop out. The last would give me positive 5 times negative 5 would give me negative 25, so that I have 3 minus 25, which would be negative 22. Rationalizing the denominator when there are two terms in the denominator. In order to do this, we have to multiply by the conjugate. The conjugate of 2 plus the square root of 3 would be 2 minus the square root of 3. 2 minus the square root of 3. So I'm going to distribute the 2. 2 times 2 is 4 minus 2 square roots of 3. So in the denominator, I'm going to go 4. I know that the outside and the inside are going to drop out, so I don't have to do the outside and the inside, but the last would be positive the square root of 3 times negative the square root of 3. A positive times a negative is a negative, and 3 times 3 would give us the square root of 9, which would turn back into 3. So I have 4 minus 2 square roots of 3 over 1, which would just give us 4 minus 2 square roots of 3. Here's another one with two terms in the denominator. 7 minus the square root of x, so I'm going to have to multiply by the conjugate, which would be 7 plus the square root of x. 7 plus the square root of x. So I'll start off by distributing the first one. 2 square roots of 5 times 7 would be 14 square roots of 5. 2 square roots of 5 times the square root of x would be plus 2 square roots of 5x. The first here would be 7 times 7 would be 49. The outside and the inside are going to drop out, so I can do the last now. Negative times a positive is a negative, and the square root of x times the square root of x gives me the square root of x squared, which is just x. This one will not reduce. This is the last one in this group, and I had to remake this video because I said something when I made it earlier, so I'm going to try not to make that same mistake. I'm going to multiply by the conjugate, which is 4 plus 5 square roots of 2. 4 plus 5 square roots of 2. And when I multiply, I'll have 4 times the square root of 3 would be 4 square roots of 3. Plus, that would be 5 square roots of 6. So when I multiply the first, I'll have 16. The outside, it's not any point in putting this down, but I'm going to, just for the record, put this down this time because I said I would. Plus 20 square roots of 2. The inside is minus 20 square roots of 2, which does indeed drop out. And the last, a negative times a positive, would be a negative. 5 times 5 is 25. And the square root of 2 times the square root of 2 is the square root of 4, which turns back into a 2. So I have 4 square roots of 3 plus 5 square roots of 6 over 16 minus 50. Or I have 4 square roots of 3 plus 5 square roots of 6 over negative 34. My math lab will allow you to leave a negative in the denominator. This is Jo Karen Hudson. Thank you, and have a wonderful day.